Day 2 officially of Algebra 2, Tuesday, March 25th. And for our do now, we are simplifying these four expressions. For number 1, I have -4, and then I have in parentheses 3x plus 10. Can anybody tell me what is going on here? What are we going to need to do to simplify this? We're going to need to distribute, absolutely. So how would I go about doing that?
-4 times 3x.
-4 times 3x.
-4 times 10.
And -4 times 10. Good. So we'll do the first step first. What is -4 times 3x?
-12.
Perfect. Okay, that's -12x. And how about -4 times 10?
Take away 6.
Take away 6. Ooh, if we were adding them, we would.
I'm sorry, -4 times 10.
Yes.
-4 times 10 is -40.
Perfect. -40. So because we're getting a -40, that plus changes to -40. Are we done? Is that our answer?
Yeah.
We are. We're done. It's simplified. That's as far as we can go. So we'll circle it, and that is it. So that's a good catch on that one, because especially yesterday when we started talking about exponent multiplication, it's super easy to forget, when am I multiplying, when am I adding? In this case, we're not messing with exponents, we're just doing regular old multiplication. So we're getting -12x minus 40. That is our simplified answer. Does anybody have questions about how we got that for number 1? Okay. Let's look at number 2 then. Got something a little bit different now. On number 2, I've got 4 terms here. 9x squared plus 2x minus 3x squared minus 8x. What's going on here, and how am I going to go about simplifying this?
I group them up.
I'm going to group them up. So how am I going to group these?
9x 2. Take away 3x2.
Good. So I have 9x squared, and the other term with x squared is that -3x squared. So these two can be combined. They're like terms, just like we talked about yesterday. So I know those go together. What is 9x squared minus 3x squared?
6x.
6x squared. 9 minus 3 gives us 6, and then our variable and exponent don't change. We're just adding and subtracting here. And what else can I group?
2x.
-8. Yeah. So I've got 2x minus 8x. Why are we putting those two together?
Because they're the same.
They're the same. They both have an x and no exponent. Same variable, they're like terms. So how do I combine 2x and -8x?
2x, -8x.
Yeah, we're just gonna kind of put them right next to each other. 2x minus 8x. And what does that give us as an answer?
-6x.
Yes, -6x. Are we done? Is that it?
No.
Oh, we're not. What else is there?
Yeah.
Yes, we are. We're done. That's all there is to it. This is our answer. 6x squared minus 6x. We cannot combine them any further. Can anybody tell me why I can't combine them any further? They're different terms. Thank you. Even though they both have x, my first term has a square, x squared. If the exponents aren't the same, we cannot combine them. So this is as far as we can go. Any questions on number 2? Okay, let's move on to number 3 then. What kind of problem is this? What's going on here, and how can we simplify it? Same word as on number 1.
Distribute.
Yeah, we're going to be distributing. Anytime I have a quantity or a number or a term, outside of parentheses. We're multiplying. Since there's two terms in the parentheses, we need to multiply both terms, which is distribution. So, Kiana, tell me, what am I going to do first here?
3x times 2x squared.
Yes, 3x times 2x squared. Yeah, okay, so we have 3 times 2 is 6. And then we have our x times x squared. So we got the 6 part right, the x part right. Now what happens if I have x times x squared? We're adding kind of. We're doing, what's kind of the invisible number when there's not an exponent written? 1. So really this is 3x to the first power. And then 2x to the second power. So there's a 1x here, there's 2 x's here. How many x's will I have altogether? 3. So my answer is going to be 6x to the third power. Remember, whenever we multiply exponents, we add the amount of numbers that's going on there. So like a quick side note, I'll do this in a separate color. See, if I do x times x, because there's 2 x's, we have x squared. So if I did x times x squared, well, I know that x squared is the same as x times x. So really, there's 3 x's total. That's how we're getting that x to the third power in our answer. Okay, so we'll go back to that work. We've multiplied our first two terms, 3x times 2x squared. What do we need to do next?
3 times 4.
Yes. Now, not just 3 times 4.
3 times x. Yeah, x times 4.
Yes, 3x times 4, which is going to give us what?
12x.
12x. Good. Are we done? Is that it? Yes. Yes, that's as far as we can go. These are not like terms. They have different exponents. We cannot add them together. That is as far as we can go. That's our answer. Awesome, awesome. Do we have any questions on number 3? Okay. Let's look at the last one here, number 4. In the previous 3 problems, we were either multiplying or adding and subtracting. Hi, come on in. Okay, so now we are on the 4th problem. And this one might look a little scary. A little bit. What's going on here? We've got division. Yes. When you see 2 values separated by a line, we're dividing. They are being divided by that line. It's a fraction, but we're dividing. So, how do I simplify this?
50 divided by 5.
Yes, yes. We're going to start with the coefficients first, the number before the letters. So I've got 50 divided by 5. What is that going to give me?
10.
10. So I'm going to cross those off because I know I'm done simplifying. And I'll write 10. 50 divided by 5 is 10. What do I do next?
12 divided by 8.
Ooh, so if it was,
Minus.
yes, this is where it gets really tricky. Remembering that when we have exponents that are being divided, we're really subtracting. So x to the 12th power divided by x to the 6th power. Let me visualize that for you. I'm going to give 12 x's over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here's my x to the 12th power over my x to the 6th power. 1, 2, 3, 4, 5, 6. Whenever you have a fraction like this, and you have the same term on the top as the bottom, what happens to those 2 terms? They cancel out. So let's see how many of these x's we can cancel. How many are matching on the top and the bottom? I'll use a different color here. So I've got one pair of x's, those cancel. I've got another pair, those cancel. Another pair, those cancel. Another, and another. If I did it properly, 1, 2, 3, 4, 5, 6. Yes, we should have 6 x's that cancel out. How many x's do I have left? 6. So really what we did here is x to the 12th power divided by x to the 6th power. We really just did 12 minus 6. And we ended up with an answer of 6 left over. So x to the 12th divided by x to the 6th is x to the 6th power. There are 6 x's left over. We really just did 12 minus 6. So whenever we multiply exponents, we add the numbers. When we divide them, we subtract. Good little note to make. That's important. You'll see this a lot here in this class, working with these exponents. Any questions about any of these 4 problems at all?
Are we gonna practice more than?
Yes, we absolutely will. It'll get kind of blended in and mixed in with the next few things that we do. So there will be practice involved, lots of it. Now, one thing I do want to kind of reiterate to you guys is at any point when I am showing you something, if you are confused, if you are lost, if you don't even know what to ask because you're not sure where to start, let me know that because I promise I will not be frustrated with you. My whole goal here is for you guys to not leave this room confused. I want you to feel confident and comfortable in doing these things. And if you don't feel that way, let me know and we'll get you feeling that way. Okay. I am here to support you all, but I cannot do that if you don't tell me that you need it. Okay. And obviously, if talking in front of a big class of students is a little nerve wracking, you can always come and talk to me in a passing period or send me an email. If you write me a note and put it in the turn in bin, pretend you're turning an assignment in, I read that. Okay. You can always communicate that way as well. So let's go ahead and put this to the side. If you build this out, you get your participation points. Woo! So don't worry about turning this in. The do nows are just kind of our warm-up activities each day. I don't grade them for accuracy again. That is just yours to keep. This is extra practice. So we're gonna go ahead and get out some notes. If this is your first day and you do not have a notebook, I have plenty of notebooks up at the front of the room over to the right side. They are on the second shelf of that little bookshelf up there at the front. Feel free to help yourself. There are plenty of them, lots of paper, pencils, take whatever you need. And I'm gonna go ahead and just title my paper, but I'll give you guys a minute to get everything out and ready before we really get started. Page burnouts. Ready?
Learning notes from yesterday.
Yes, we do have a few notes from yesterday, and I have them right here. So I'm gonna flash these on the screen for anybody that wasn't here yesterday. And I also want to mention, if you ever do miss a day, yesterday or in the future, everything that you miss, because we do record our lessons, you will have full access to see anything. We did a really short lesson yesterday just because it was the first day. But all we did, here's yesterday's notes. I can always also, if you ever want a copy of the notes that you missed, let me know. I will happily do that for you. We just reviewed what like terms are, meaning numbers with the same variable and exponent. So like if they all have an x attached, we can add and subtract them. If one has an x squared and one has an x, you can't put them together. Only the x squareds go together. Only the x's go together. So those are kind of that little like term review. Then we talked about distribution, which is just telling us what to do whenever there's a number outside of the set of numbers in parentheses, which is multiplying 5 times x, 5 times 3, 5x, 50. Simple stuff. But again, I will happily make copies. And then the last thing we talked about was just these two things, exponent multiplication and exponent division. Now, if you were not here yesterday, this is a really good thing to write down. If you don't, this whole page would take you a while to write. But in what I'm about to circle here, this is a great thing to keep in your notes. The multiplication part, where you add the exponent values, and the division part, where you subtract the values. Okay, so this is a good kind of formula to help guide. Now, if you're looking at this and you're like, that actually doesn't make any sense to me, okay? Come and talk to me later. I'm happy to get you caught up, okay? And also know that this video from yesterday's lesson is available online, so you will have access to that. And I'll show you how if you're not sure how. So I'm going to move this to the side. Come find me later if you need copies of that or want to see it again. But let's get started on today's notes. So we did that review yesterday. And today we are going to kind of put that review into practice and start something a little bit different. I want to introduce a word to you that some of you probably already know if you took Algebra 1 last term. I'm going to write the word binomial. Binomials. Does anybody remember what a binomial is?
2 numbers.
2 numbers. Oh my goodness, yes. So you can break this down very easily. Bi means 2. Bi means 2. Nomial is a fancy word for number or term. So a binomial is just a fancy way of saying 2 numbers or 2 terms. So for example, here's a binomial, x plus 5. There's 2 terms here. I have x, I have 5. That is a binomial. Now, there are things that we can do with binomials. For example, something we did yesterday is that distribution, where you multiply just a number times the binomial. And that's not too complicated. But here's where it gets just a little trickier. If I want you to multiply 2 binomials by each other. So what if I had x plus 5, for example, times x plus 2? What would I do if I wanted to multiply these?
Start with the x's, is it?
Yeah.
So 2x or x to
Yes.
the second power.
X to the second power. Great. So we're going to start with our x's first. We're kind of going with our first terms here. So I'm going to draw little arcs and arrows to show what I'm multiplying each step. So perfect. X times x is x squared. And that's what I would do next.
5 times x.
5 times x. You could do that next. You absolutely could. Let's see what happens if I do that. Let's do 5 times x, sure. Okay, so I'm gonna put that down. 5 times x is what? 5x, good. Okay, is that it? Am I done?
Plus 2.
Oh, plus 2?
Plus 2.
Could be. Do I need to just bring that plus 2 down or should I do something different?
5 times 2.
Yeah.
The 5 times 2? Okay, let's do that. So 5 times 2, what's that going to give me? 10. Okay. Am I done?
X times 2.
Oh, we're missing one thing. Yes. I still need to do x times 2. Now,
That
this
should
looks,
have been before 5 times x.
yes, and that's okay. We'll talk about it. So x times 2 is 2x. All right. This looks like a lot to keep track of. What is happening here? I am going to give you an easier method than trying to guess and make sure that you've multiplied every term by every term. This is going to be much easier when we break it down. So when we multiply binomials, here's what happens. We're going to multiply my first term by both of these terms. I'm distributing x to x plus 2. So x times x and then x times 2. Then I take my next term and I distribute it. 5 times x, 5 times 2. And this is a fancy little method that I call, well, I don't call it this. Some mathematician calls it this. It's called the FOIL method. And I will explain what that means here in just a moment. FOIL method. Now, before we get into the FOIL method, we've got all these terms written out. I have x squared plus 5x plus 10 plus 2x. Is this simplified? No. What should I do to simplify it? Yes, I need to group and combine my like terms. Do I have any other x squareds to combine? No. How about x's? Yes, I have 5x and 2x. What happens when I put those together? You add them, yes. So what's 5x plus 2x?
7x.
7x. So my final answer is going to be x squared plus 7x plus 10. And we'll circle that. So this was kind of like the discovery part of this lesson. I just wanted to see who knows how to do it. And now I'm going to actually teach you how to do it. So if you feel lost right now, not to worry. We're going to get you found. So let's talk about this FOIL method. And I'm going to give you a new problem to do that. Let's do x plus 12 times x plus 3. So we're going to write out to the side FOIL. Can I move my paper down? Does anyone still need this? Okay, I'll scooch that down. Does anybody know what the F stands for?
First.
First. So I'm going to write over to the side. First. Anyone know what O means?
Outer.
Outer. How about I?
Inner.
Inner. And L?
Last.
Last. So what we're doing here is for the F part of FOIL, for the first, we are going to multiply the first term of both binomials. Here's the first term, x. Here's the other first term, x. So for my first terms, I'm doing x times x, which is what? X squared. Good. So there's the first term of our FOIL. Now we're going to look at O, the outer term. So what we're going to do for that is I'm going to start with the outside terms. These are the inside. This is the outside. So I'm going to take x times 3. Those are my outer terms. What is x times 3? 3x. Good. Next, we'll do the inner terms. What are the inner terms going to be? 12 times x. So let's write that. 12 times x. What does that give me?
12x.
12x. Good. And what would my last terms be?
12 plus 3.
Yes, 12 and 3. And what is 12 times 3?
36.
36. Let me throw that one. That's right. Six. Okay, perfect. Okay, so we have now done all of the 4 steps. First, outer, inner, and last. How do we turn these 4 terms into an answer that's written out? I'm gonna just pull them out. X squared
Plus 3x
plus 3x
plus 12x
plus 12x.
plus 36.
Perfect, plus 36. Is that simplified?
No.
No, what do I need to do?
Group by
My like terms, let's combine them. I've got 3x and 12x, which gives me what? Yeah, what does that give me?
15x.
15x. So I'm going to rewrite my other terms. X squared plus 15x plus 36. And that's our answer. We multiplied binomials. Amazing. Amazing. Okay. This is review if you have had Algebra 1. If not, this might be new to you. But does this make sense to everybody? Going through step by step, does it make sense the steps we are taking?
Yeah.
Is anybody completely lost?
I can do it.
That's good. That's good. Okay, let's do another one. Let's do another one. What if I throw in some coefficients on these x's? What if I give you, and here I'm gonna make it obvious that those are different problems. How about this time we have 2x plus 4 times, let's do 3x minus 2.
Okay.
Yes,
You slow down.
absolutely. Do you still need to see what's up here?
No, I got it.
Okay, perfect. Okay. No, I appreciate you saying something. Yeah, if at any point we're going through something and you want me to slow down, tell me, please. Please tell me. I won't be bothered by it. I appreciate you speaking up. I do. Okay. So let's see here. Would somebody like to guide me through how to do this?
Good. 3x.
Yes, we'll do the first terms, 2x times 3x, which gives us
6x.
6x what?
Squared.
One little thing. Yes, x squared. We did 2 times 3 is 6. Then x times x. That's where it gets a little bit tricky sometimes. We can forget to write squared. 6x squared. So there's our first term. What do we do next?
2x. -2.
Perfect. 2x times -2. That's the outer terms. What will that give us? -4 what?
X.
-4x. Good. What's next?
4 times 3.
Perfect. 4 times 3 what?
12x.
Perfect. 12x. And last but not least, what do we do?
4 times -2.
Yes, 4 times -2, which gives us
-6.
I mean 8. Yes, -8. Good. Good, good, good. Okay, so we have done the FOIL. What's left to do next? We want to combine our like terms. usually it's going to be those two middle terms. Actually, if you use the FOIL method, it will always be the two middle terms. If you do it in a different order, it might be different. Like in our first problem, we didn't do the FOIL method on the first problem. That's why our like terms were in separate places. But in the last two examples, and forever and ever, if you use this method, your like terms will always be in the middle. So what is negative 4x plus 12x? 8x. So I'm going to rewrite everything with my new combined middle term. 6x squared plus 8x minus 8. And that's my answer. Very nice. Okay. You guys think you can do some of these on your own? Can I give you some? Or do we want to go through more together? Yes.
Can you, go down before I can get the little part when I walked out?
Which- Up here?
Yeah, right there.
Okay, yes, absolutely. Stop for just a second. All right. So there's our first page. Let's go ahead and start a second page. And you know what? Before I give you problems, I'm going to show you the second method of doing this. Maybe you don't like the FOIL method. Last term in Algebra 1, a lot of my students preferred what we call the box method. It's a more visual method. So it really depends on if you are more of a visual learner or if I don't know, some people think it's satisfying. Depends on your preference. Let's see, page 2. I'm going to title this so you guys have a minute. Algebra 2. So you've got a page of notes about the FOIL method. Let's now continue talking about binomials and look at the box method. And for this method, I am going to use one of the problems we've already solved, just so that I can show you that we will get the same answer no matter which method you use. So the great thing about these two, FOIL versus box, is that if you like the box method and hate the FOIL method, you never have to use the FOIL method. If you hate the box and like the FOIL, you never have to use the box. It's up to you, whatever you like, you will get the same answer every time. So with the box method, let's look at the same problem that we did second on the last page. We had x plus 12 times x plus 3. And for the box method, it's going to be exactly what it sounds like. We're going to draw a nice little box. And it needs to have 4 quadrants in it. So what I'm going to do is just draw a box like this. And then a line down the middle, going both ways like that. So I'll give you guys a moment to get all of that. Okay, so now we're going to use the box method to multiply these binomials. And here's how we do that. I'm going to start with my first binomial, x plus 12. And what I will do is I will take these two terms and write them over the top of each of the two boxes here. So my first term is x. I'm going to write x right here. My next term is 12. We're going to put 12 right here. Completely optional, you could include the plus just to remind yourself it's positive 12. The only issue I see with this is I've seen on some students on their work, they'll write plus 12 and accidentally add instead of multiplying. So just make sure you're aware that when we are doing this, we're multiplying, just like with FOIL. So we've got x plus 12 written there. Now we look at the second binomial, x plus 3, and we're going to write that over to the side. My first term is x, so it goes here. My second term is that plus 3, so I'm going to write plus 3 over here. Second box. So once you have that all written out, box method works just like a multiplication chart. If you don't know what a multiplication chart is, I believe that there are some at each of your tables. It looks like something like this. And basically how it works, these are a great tool. I use them myself sometimes. Many students use them. Keep them out on your desk. You're welcome to use them at any time. But on a multiplication chart, the way it works is whichever number I go over to, for example, 7, as I go down, whatever number it lines up with, that's what I'm multiplying it by. So for example, 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. And I could go on and on and on. So for the box method, we're doing the same thing. In this first box, I have x times x. What does that give me? X squared. Good. So that's what we write in our first box. And let me zoom in on this. I know it's kind of tiny. Okay, so what would I be multiplying to get the answer for the second box? X times 12, good. Which gives me what? 12x. So again, optional, but I like to do this. I'm going to write, because I know it's a positive, plus 12x. You don't have to write plus. If you don't, I'm not going to take points off of you. It's really a preference. So let's go now to this box down here at the bottom left. What two terms do I multiply to get this one? 3 and x. Good. And that gives us 3x. And last but not least,
3 times 12.
Perfect. 3 times 12, which is 36. All right. So with the box method, you're going to notice get the same numbers as we would have with the FOIL method. If I can show these side by side. Let's see. We got an x squared, a 3x, a 12x, and a 36. Pretty cool. It works both ways. Now, to get your final answer, though, we still need to do combining like terms and make sure that we pull all of these out of the box and write it properly. And what are our like terms here?
3x and 12x.
3x and 12x. And using the box method, when we multiply binomials, your like terms are typically always going to be in this little diagonal pattern here. So we will write them out. I know 12x and 3x, when I add them together, I get 15x. So my final answer is pulling all of these out. I get x squared plus 15x plus 36, which is the same answer we got using the FOIL method. Same answer there. Right. Any questions about this problem? Is that all making sense to us? I hope so. That's good. Okay. We'll do one more together, and then I will have you guys try some on your own. So let's do that second problem once more. 2x plus 4.
Are you doing this the box method also?
Yes, yes, the box method again. Times 3x minus 2. And we'll draw a box again. So what goes on top of the box? Yes, go ahead.
2x and 4.
Yes, 2x and then my 4 plus 4. And what goes on the side?
3x
Mm-hmm.
and -2.
Yes, 3x and -2. Now, I say that using the plus signs is optional. The minus signs, not optional. If you forget to put -2 over here, you're going to end up with a +8 and an incorrect answer. Okay, so let's solve this one now. Hi, Jesse. Come on in. We have, here, pause this real quick. All right, so somebody guide me. What do I do to get the answer for the first box?
6x.
6x, how'd you get that?
3 times 2.
Okay, 3 times 2 is 6, and then,
And the x is
okay, so the x is, x times x is
x squared.
x squared. Very close, very close. It's good. So we have 6x squared. Now how do I get this number?
4 or 3 times 4.
Yes, 3x times 4 is
12x.
good, 12x. Now, bottom box, I've got what two terms do I multiply?
-3 or -2
Mhm.
times
Perfect. -2 times 2x is
4.
-4. What?
X.
X. Good. Don't forget your x's. -4x. And last but not least,
-2 times 4.
good. -2 times 4 is
-8.
-8. Okay. So we've got our four terms. Can anything be combined?
-4.
Oh, maybe.
So
We have two terms with x's. Our middle terms, or these diagonal terms here, I've got 12x minus 4x, right? You not seeing that on your paper?
I see it, but I thought like when they have a different negative or positive that you don't do anything.
So it's okay if they have a different sign. Like I have a plus 12x minus 4x, that's okay. The only thing that we can't combine is when they have a different exponent or a different variable. So since they're both x's and they both don't have an exponent, we can combine them. So how do I combine 12 and -4 x's for both? Subtract them. Good. So what's 12 minus 4? 8. So we are going to get 6x squared plus 8x minus 8, which is exactly what we got when we did it with the FOIL method. See that? So it works. Okay. Any questions about either of those methods, the FOIL or the box? Okay. You guys feel like you can do some on your own? Let's try. Let's try. So I am going to give you guys some practice problems. Let me just pause this screen for a moment. Okay, so I'm gonna just start a new page and write out some problems. Once I finish writing these out, I am gonna make copies of things for some people that weren't here yesterday or people that just need copies of stuff. So if you want a copy of these practice problems that I write down, let me know and I will do that for you. And if you know that you're going to work off the copy, you don't need to write this down. I'm just going to for you. So, this is page 3 of our notes. Practice on your own. And what you're going to do is multiply each of the binomials I give you. And you can choose the box method or the FOIL method, whichever you prefer. Will be a bit of a challenge. Just an optional one. See if you can do it. So I am going to make copies of this. If you don't want to sit and write all of these down, you're welcome to wait for that copy. And when I get back with that copy, I'm going to give you guys about 20 minutes to work on these. While you're working on them, if you would like any one-on-one help or assistance, just shout at me, raise your hand, let me know. I'll come around and help you guys. But I'm going to pause this. And so we are back from our little break. And let's just quickly go through these. As I give you the solved answers, please stop me if you got something different and if you would like me to explain anything further. All right. So number 1, we are multiplying x plus 5 times x minus 3. I'm going to use the FOIL method to demonstrate this first one. We're going to just kind of go back and forth. We'll do box for 2, FOIL 3, box 4, etc., etc. So for number 1, actually, I would like to know, would somebody like to guide me through number 1 that did the FOIL method?
X times X.
Yes, thank you. X times X comes first. What's that give me?
X squared.
X squared. What's the next step?
X times -3.
Yes, X times -3, which is?
-3x.
Good, -3x. What's next?
5 times x.
Yes, 5 times x, which is? 5x. And last but not least?
5 times negative.
Good. 5 times -3 is -15. Okay, so whether you did FOIL or box, these are the 4 terms you should have come up with. And which two get combined? Yes, -3x plus 5x. And what does that give us in the middle term? 2x. So we're going to rewrite our answer with the combined like terms as x squared plus 2x minus 15. And that is our answer for number 1. Did anybody get something different and they're not sure how they got something different? Or did we get that one? Any questions on number 1? Everybody feel okay about that? Okay, don't be scared to stop me if you would like a different explanation.
-2x.
Why is it not -2x? That's a great question. So our middle terms are -3x and +5x. So let's write those out. I have -3x plus 5x. So whenever we have a negative number and a positive number, we are going to use the sign of whichever number has the greater value. So if I have a -3 and a +5, which value is greater? The +5, it has a greater absolute value. So really what's happening here is I'm taking 5 and I'm adding -3, which is the same thing as 5 minus 3. So we are going to end up with a +2x. Now, something you can also do if you ever get stuck and aren't sure, I encourage you to use a calculator. You can use them in real life, you can use them in this room. So, quick review on how to type in a negative number in case you're not sure. There should be calculators at your tables. If anyone doesn't have a calculator, let me know. Does everybody have one if they want one?
You need to get more, because we'll probably fight over them.
Probably. And you know what else we have is in the back of the room by the computers, we have all these yellow calculators. Those are the fancy ones. They're graphing calculators. We don't technically need them for this, but you're welcome to use those if you're more comfortable on them. The graphing calculators look a little bit more like something like this. This is the one that I used when I was in college. So it's slightly different from the yellow, but it's got all the same buttons. You don't need them today, but if you would like one, you're welcome to use it. But quick review of how we type in a negative number. If I want to know what is -3x plus 5x, I'm going to type in negative. Here's my negative sign right here at the bottom. Push that. -3 plus 5. And I will get enter equal to +2. So this is a great way to check your answers. I'm never going to be upset for using a calculator. I highly encourage it. I use a calculator to check your work too. So better safe than sorry. Any other questions on number 1? Does that clarify that for you, Cheyenne?
Yes.
Thank you. All right. Let's look at number 2. Does anybody feel good about number 2 who did the box method and would like to guide us through using the box method for number 2? Anybody?
It's gonna be 2x on top and then -6
Good.
to it.
2x minus 6 goes on top.
And then down the side it's gonna be x and then +1.
Perfect. Down the side we'll write x plus 1.
So it's gonna be 2x squared.
Good. 2x times x is 2x squared. Is this too small? I'll zoom in. Can you see that a little better? Hopefully. Okay, so we've got 2x squared. What did you do next, Amanda?
Then I got a -6x.
Perfect. -6x in the next box.
And then down in the corner I've got 2x.
Perfect. 2x times 1 plus 2x. And finally,
-5.
-5. Okay. We have -6 times 1. What's that going to be?
-6.
Okay, so this is something I saw a lot while walking around the room. It's very easy to accidentally add the numbers instead of multiplying. So we have -6 and 1. We're multiplying those, not adding. So we're going to get -6. And Ella, I have a worksheet up there on the front. That's what we're going over right now. And I can get you a copy of what you missed earlier, so no problem. Happy that you're here. I'm gonna mark that you're here before I forget. Finish. All right, great. So Amanda, go ahead and finish helping us solve this one. We've got all of our 4 terms. What do we do next?
It's gonna be 2x squared.
Mm-hmm.
And then I'm gonna take my -6 and add 2 to get -4x.
Yes. So I'm gonna write this out and then I'll combine them. I've got -6x plus 2x. And you said that's gonna come out to -4x?
Yeah.
That is correct. Perfect.
And then -6.
minus 6. So our total written out answer is 2x squared minus 4x minus 6 for number 2. Go. Right. Any questions on problem number 2? Everybody feeling okay about number 2? Did we all get this answer?
Yeah.
Okay, great. Great. Yes. Okay, let's go ahead and look at number 3 now. We will flip back to the FOIL method. What are we going to do first? We're going to distribute, starting with 5x and which term?
3x.
3x. What's 5x times 3x?
15x to the second power.
Good. 15x to the second power. What do we do next?
5x times -4.
Good. 5x times -4, which gives us,
-20x.
good, -20x. What do we do next?
2 times 3.
6x.
Yes. 2 times 3x gives us plus 6x. And last but not least, yeah, 2 times -4, which gives us -8. All right, so whichever method you used, we should have these 4 terms: 15x squared minus 20x plus 6x minus 8. What do we do from here? Combine like terms. What is -20x plus 6x? -14x. So we write out our answer again with the new middle term, 15x squared minus 14x minus 8. And that's our answer for number 3. All right, any questions on number 3? Everybody got that one? Okay. Let's go to number 4. And we'll go back to the box method one more time. So I'm going to draw my box, and what goes on top of the box?
Then plus 12.
Perfect. We're going to start with our first binomial, x plus 12.
Then on the side you have x. Then -20.
Good. Then on the side, we have x minus 20. Okay. So we've got our box all set up. Where do we go from here?
Times x.
X times x.
X squared.
X squared. Good.
Times 12. Plus 12x.
Yes. Plus 12x.
And then x times -20 and -20x.
Negative 20x. And
12 times -20 is -240.
negative 240. Is that right? I didn't work that one out. Everybody got that? Good. So negative 240. Big number. I bet that threw some of you off. It happens sometimes. So where do we go from here? Combine our like terms. So I'm going to go ahead and pull out my x squared. We've got these 2 middle terms here. Got negative 20x plus 12x. And what's that going to give us? Negative 8x. And last but not least, we just stick on that minus 240 at the end. There we go. That's our answer. That is our answer. Okay. Any questions on number 4? All right. Number 5 is just like the others. However, it's a little bit trickier because this time, instead of just having x terms as your first term, I gave you 5x to the third power plus 2x as your first binomial here. And your second binomial, we've got 4x squared plus 3x. So, how would we go about solving this one?
5x times 4x, and then
Yeah.
you add the thingies.
The exponents, the powers, yes. So you're doing the same exact process. You just have to keep track of your exponents. I'm gonna draw my little arrow. I'm doing 5x to the third power times 4x to the second power. So now we're doing a little bit of exponent multiplication. We'll start with our coefficients. What is 5 times 4? 20. Now, x to the third power times x to the second power. X to the fifth power. Good. Remember, when we multiply powers or exponents, we add. So 3 plus 2 is 5. That's where that number's coming from, okay? All right, let's go to the next set of terms. We just did the first ones. What do I do next?
To the third power times 3x.
Good. 5x to the third power times 3x. So again, we'll start with the coefficients. 5 times 3 is 15. And now I have x to the third power times x.
X to the fourth power.
X to the fourth power. Good. Remember, there's like an invisible 1 there. X to the first power. So we're doing 3 plus 1. And that's how we get our 4. Okay, so I've got that. What do I do next?
2x times 4x squared.
Good. 2x times 4x squared. What's 2 times 4?
8.
8. And x times x squared is?
To the third power.
X to the third power. Good. Okay, so we've got that. And last but not least, what do we do next?
2x times 3x.
2x times 3x, which is?
6x squared.
Good. 6x squared. Now, this one is unique. What is different about this problem now that we have our answers written out?
There's no like term.
There are no like
So
terms.
it's simple.
So it's already simplified. Every single exponent has a different number, a different power. 5, 4, 3, and 2. You cannot put any of them together. That's our answer. We only combine if they are the same terms. These are not. They're different, so we're done. All right. How do we feel about multiplying binomials?
Go ahead and give us a quiz.
Oh yeah, you ready for the quiz? Man. No, that's pretty good, you guys. Awesome. Do we have any questions at all? Anything?
Can you go up to the second one, please?
Yeah, absolutely. Do you have a question about the second one, or are you just wanting to see the work?
Somehow, I got like 2x negative 2x squared negative 3x minus 6.
Okay, so -3. What were your original 4 terms that you had? You have 2x squared. Do you have that part? Do you have minus 6x? Do you have plus 2x?
And then I put 3x for some reason. I don't know why.
It could have just been a silly mistake. Maybe you just wrote it differently. Or maybe you said you got minus 3x as your middle term?
Yeah.
I wonder if you divided, like -6 divided by 2
Yeah, I think I
Instead of-
did.
instead of subtracting. That might have been what happened. I wonder. Yeah, that's probably the trickiest part, is remembering which operation to use. Because as we FOIL or use the box method, we're always multiplying. But once we have our terms and we combine, that's when we add and subtract. Unless, of course, we're looking at exponents. So it's easy to jumble it up. But does it make sense to you how we got -4x as the middle?
Yeah, I just wanted to see because I did silly work, I guess.
That's okay. It happens. We all make mistakes. Even I do. I'm sure you'll catch me at some point. So, okay, guys, that's our practice. One last chance. Any questions? Okay, I'm going to go ahead and move this on. And it is the second half of our class, which means we're doing another little lesson here. And we're gonna take a few more notes. So much fun. So I'm gonna title my page again, Algebra 2. You guys are doing great. And this is page 4 now. Now, with the end of that little review of the FOIL and box method, multiplying those binomials, this really does kind of conclude the end of that Algebra 1 review. If you would like more of this specific review, let me know. I'm happy to make you practice worksheets, things like that. Just communicate with me. I will help you out. So this is day 2 notes continued. So now that we have done a whole lot of that review, we remember how to multiply, we know our exponent rules. We're gonna keep those in mind as I introduce something new to you. This might be the first time you've ever seen something like this. My Algebra 1 friends from last term, I did not teach you this. This will be new, okay? So we are gonna learn about something called quadratic equation. There is a certain form that this will normally be in. Now, the key word here is equations. We have been working with, since yesterday, expressions, okay? Now, these are fancy words. An expression versus an equation. Does anyone know the difference, or are these pretty foreign?
There's an equal sign.
There's an equal sign, yes. So in all of these problems, we've just been simplifying. These are expressions. There's no equal sign. We didn't solve anything. We just simplified. Now we have problems where there's going to be an equal sign involved, okay? Now, I'm going to give you kind of the form of what it will look like. And that form is ax squared plus bx plus c. And for now, we're going to always have it equal to 0. Ax squared plus bx plus c equals 0. This is known as a quadratic equation because there is a term with x squared. Anytime you have an equation that starts with x squared, it's called a quadratic equation. If you'll notice, whenever we multiplied all the binomials before, our answers came out to be quadratic equations. X squared plus x minus or plus a number here. So we're going to talk about going in the opposite direction. We went from 2 binomials getting to a fully written out quadratic expression here. Now we're going to go from the quadratic back to the binomials. We're going backwards. I'm going to teach you today about something called factoring. So, factoring. We're going to use this method of factoring to solve these equations, okay? Now, a factor is a fancy word for finding the items that multiply together to give you what you started with. So, for example, we'll start simple. If I have x squared, the factors of x squared would be x and x, because when I multiply them together, I get x squared. So the factors are x and x. Factors are what we use to multiply to get to the answer. What about if I gave you, let's see, 35, it's a number. There's going to be more than just one pair of factors here. You're going to have multiple options. So we're going to list them out. The simplest way to think about factors is to start with the smallest number you can think of. I can start with 1. 1 times what makes 35? 35. So here's a set of factors. 1 times 35. Can I do 2 times something to get 35? Not a whole number, so we're going to skip 2. It would be, let me think, what would that be, 17.5? Something like that. With factors, we only want whole numbers. So we have 1 and 35. We can't do 2. Can we do 3? No, we can't do 3. Can we do 4? Mm-mm. Can we do 5?
Yeah.
Yes. So what do I do 5 times to get 35? 7. And the trick to figuring that out is I can do 35 divided by 5. And that gives me 7. So 5 times 7 is a factor. Can I do 6? And the next number is 7. So I've already got 7 written down. These are my 2 sets of factors for 35. I could do 1 times 35. I could do 5 times 7. So just as a little introductory, we're looking for the items we can take and multiply together. Those are our factors. Now let's look at something more complicated. Let's look at a quadratic equation. Let's look at the answer that we got for number 1, x squared plus 2x minus 15. Now, as we move more into the equation side of things, we'll include that equals 0 at the end. But to be completely honest, I think I jumped ahead of myself a little bit. Let's not worry about the equal sign just yet. We're just going to worry about the fact that this is called a quadratic, okay? So we have x squared plus 2x minus 15. And I'm going to show you how to factor this. Now, as I show you this first example, you might want to just watch and experience it before trying to write every little thing down and accidentally missing a step. So let me just show you first, and then I'll give you time to write, unless, of course, you're great at multitasking. So whenever I want to factor a quadratic expression, such as this, I'm trying to figure out what 2 things can I multiply together to get this. That sounds really complicated because we know by looking at the practice problem, these are the 2 things we multiplied to get that. So how on earth are we going to get to this answer? We're going to use a few methods. First of all, what I want to do is look at that form, the quadratic equation form. I have a, b, and c. ax squared, bx, and c. So I'm going to line that up with this problem here. I have ax squared plus bx plus c. Okay. The first thing that I want you to do, and you can write this part along with me, is I want you to be able to identify which number is my A, which number is my B, and which number is my C. So we're going to write off to the side A, B, and C. A, B, and C are going to be the numbers, the coefficients that are in front of the variable, except for C, there is no variable. C will just be the number that we have written. So ax squared, what is the number in front of my x squared here? 1. There is no number, so we assume it's 1. So what is our A? 1. What's our B?
2.
2. What's our C? Negative 15. Good. So pay attention. If you have minus 15, it's negative 15. If it was plus 15, we would keep it positive. So I now have my A, my B, and my C listed, written out, labeled. What I'm going to do next is I'm going to list out all the factors of C. And here's how we do that. I usually like to draw a little arrow out, and you don't have to write out the words factors of C, but I will just for the sake of your notes. Factors of C, which is negative 15. So I'm going to write that here. And I draw a line under it. And for these factors, what I will do is I'm going to make kind of like a T-chart. Now, if I have a negative number, I have 2 possible ways to end up with that as my product whenever I multiply. I could either do a negative times a positive or a positive times a negative, right? We have to have different signs. So let's start with negative 1. Negative 1 times what makes negative 15? So negative 1 and positive 15, when I multiply them, they give me negative 15. Can I do negative 2? Can I do negative 3? Yes, negative 3 times what? 5. So here's where I'm listing my factors. Okay, can I do 4 or negative 4? No. Can I do negative 5? Yes. Negative 5 times what? Times 3. Good. Okay, let's see. Can I do negative 6, negative 7, negative 8, negative 9, negative 10, 11, 12, 13, 14, negative 15?
Yeah.
Yeah, we can do that. Negative 15 times positive 1. Good. So the first step is labeling your ABC and finding your factors of C. So I have all my factors written out. Here's what we're going to do with those factors. Now, I am going to look at my B term, which we decided was 2, positive 2. So I'm going to go to this list of factors, and I want to see what happens when I add each pair of numbers. So let's write the answers out to the side. What is negative 1 plus 15? 14. What's negative 3 plus 5? 2. What's negative 5 plus 3? Negative 2. Negative 15 plus 1? Negative 14. Okay, so as you can see here with each pair of numbers, if I have a negative 1 and a 15, I get 14. If I have a negative 15 and a 1, I get negative 14. We're using the same numbers, we get the same answer, just with the opposite sign because we flipped the signs on which number we put it on, right? So here's what we're going to do now with all these things we just added up. This might not make a whole lot of sense until we put it all together at the end. There's a lot of steps here. So I've added my factors, and what I want to see is which pair of factors that when I add them together is going to give me the same number as my B. My B is 2. Negative 3 plus 5 gives me 2. So we're going to circle that one. And I'm gonna write over here, b equals 2. I want it to add up to b. And here is what we do next. So this is the hard part of the work. This is the easy part. Whenever we factor a quadratic, you will always end up with, as long as you start with the term that's x squared, you're going to end up with 2 parentheses. So 2 binomials, 2 sets of parentheses, where you have x plus or minus something times x plus or minus something. So we are going to write under here x plus or minus something. We're going to leave a blank. And then another x with blank. Okay, so now we have this. So here's what we do with what we found with all these factors. Since the answer of what 2 numbers add up to my b term, my middle term, are -3 and 5, I'm going to take those numbers and fill in my blanks. -3, I'm going to put that first. So x minus 3. And next I have +5, so I'll do +5. And look at this. We started with the answer to number 1, and we just factored it. This is the numbers we started with before we multiplied. Even though they're in a different order, it's still correct. It's okay if they're in a separate order. We have the same numbers here. We have an x minus 3 times x plus 5 times x plus 5. So you can see that we did it. This is our factored form. We just factored the quadratic equation or expression. Technically not an equation yet. Moving it to an equation is super easy. It's just one extra step, but I'm going to save that for just a moment. This is a lot. I just threw a bunch at you, okay? If you've never seen this, it might be overwhelming. Now, don't worry. We're going to do so much practice with this that you'll be doing this in your sleep at some point. Promise you, you'll feel so good about this by the end of the term. So this is our first example. Let's do another one just to get us used to it. I am now going to do, let's do one that's actually not on here. So let me give you a nice one. Okay. Let's do x squared plus 7x plus 10. Now, once you have this written out, remember the first step is to identify our values for A, B, and C. So that's fairly simple. We can just write A, B, C. What's our value for A? 1. What's our value for B? 7. What's our value for C? 10. Perfect. So I have my values for A, B, and C. Now we're going to move on to the next part of that first step. We're going to list out all the factors of C, of 10. So factors of 10. Now this is a positive 10. And we really only have one option here. Technically, you could do a negative times a negative to get a positive. I can explain a little more on that later, but since our middle term is also positive, we don't need to use negative numbers, so we won't worry about those for this one. But let's start with our smallest number, 1. 1 times what makes 10? 1 times 10. Can we do 2?
Yeah.
2 times what? 5. Good. And let's see, moving on from there, we can't do 3, we can't do 4. We can do 5, but technically we already did it. We could list it out for fun though, 5 and 2, and then 10 and 1. These are all the factors, all the different possibilities.
So it's just.
So what do we do next based off of what's above? Anybody catch on yet? Yeah.
You, the 5 and the 2 will
Uh-huh.
make 7.
Yes, we're adding all of these factors. I know 1 plus 10 is 11. That's not my b value. 2 plus 5 is 7. Remember, I want to find the numbers that add up to my b term. B equals 7, and 2 plus 5 equals 7. 5 plus 2 also equals 7, so technically both of these work. It does not matter which one you use, they are both correct. So I'm going to just circle both of them and say that you can either do 2 and 5 or 5 and 2. So we have our numbers, and we know that our quadratic expression factors into 2 binomials where we have x plus something or minus something and another x plus or minus something. So we're going to write our x and our x. And we just need to figure out what do we fill in those blanks with.
The 2 and 5.
The 2 and the 5. So I'm going to write plus 2 or minus 2. Plus 2 and plus 5. Good. And that's our answer. Stole that from yesterday. I can show you that it's correct. We got x plus 2 and x plus 5. We started with x squared plus 7x plus 10. It works. Okay, so we've done 2 factoring problems together now. Is anybody feeling overwhelmed? Anybody? Is this crazy or is this not too bad? Not too bad. Good. I remember when I learned this, I thought I was going to throw up. I hated factoring in high school. It was my least favorite thing to do. So this
Does
is
seem like
great.
all the work.
Yes, ugh. So I've been trying to figure out the best way to show it to you without it looking confusing. So good. All right, does anybody need this page or can I move on? Okay. All right. Let's do another one for good measure. We just want to really drill this into our brain. I've only done 2 with you. Retitle this page 5. A lot of notes today. Do x squared plus 15x plus 36. So now that I have my terms written out, what should I do first?
Identify.
Yes, let's identify our values for A, B, and C. A, B, C. What's my A? 1. What's my B? 15. And what is my C? 36. Perfect. Okay. So 115 and 36. Let's look at our factors of C. Something that I find really helps is as you're listing your factors out, before you even do that, I like to just rewrite that B equals 15 over by it, so I remember what I'm looking for. As I'm writing my factors out, I might be able to recognize quickly which set is going to add up to 15. So let's look at all the factors of 36. I could do 1 times 36. I could do 2 times what?
18
2 times 18.
Times 12.
3 times 12.
4 9.
Could I stop here?
Yeah.
This is where we start getting quick. We can stop here because why? Why can I stop here?
3 plus 12.
15?
Because 3 plus 12 is 15. So why list all the factors out if we don't need them? We'll start to get to where we can recognize right away 3 and 12 add up to, or not add up, multiply to 36, and well, 3 and 12 add up to 15. So what am I going to do with those numbers? I'm going to put them in. What's my answer going to look like? I'm going to have x.
X plus 3.
Good. X plus 3
X plus 4.
and x plus 12. Very good.
So the easiest way to do it would be just like do 36 and then to
Mhm.
find the factors and then divide by 1, 2, 3.
Yes, yes. I do think that's one of the easiest ways to do it is, and I'm going to repeat what you said in case anyone didn't hear it. You start with that number and you're just kind of dividing each one. 36 divided by 1, 36. 36 divided by 2, 18. 36 divided by 3, 12. That's how we're finding those numbers. We're doing the opposite of multiply, we're dividing. Something else I have that might be helpful. I'm going to pause this real quick while I grab it. This is an excellent help. It's a page that lists out all the factors. So if you're finding the factors of 12, look, they're already all written out for you here. 13, 14, all of them. So I'm going to pause this again, and I'm going to pass this out to anybody that is interested in having it. It's definitely very helpful. And you can even see, like, we just did 36. Where is it on here? There it is. 136, 2 and 18, 3 and 12. Yep. We could have kept going, but we just didn't need to. Oh, we had another option that would have worked. 4 and 9 add up to, no, they don't. Okay. Never mind. Don't know why I thought that worked. Okay. All right. So you all should have those factor pair worksheets. If you tried this one, awesome. Let's do it. What should I do first? Yeah, that's ABC. Our A is 1. Our B is 12. Our C is 36. What do I do next?
Factor of 36.
Factors of 36, which are
1.
36, 2 and 18, 3, 4, 9, 6 and 6.
yes. Wait, hang on. 2 and 18, 3 and 12, 4 and 9, 6 and 6. Which pair are we going to use?
56.
Why?
8 plus 6
12.
Yes. Our B is 12. 6 plus 6 is 12. So what we can do is use positive 6 and positive 6 as our fill in the blank. What's our answer?
X plus 6.
plus 6. X plus 6.
X plus 6. That's it. Very nice. Very, very nice. Okay. All right. I am going to have lots of practice for us in the future on this, but I think I'm reading the room. We're tired. We've done a lot. Yes.
You put it in X plus 6 squared.
Yes. Oh my gosh. I didn't even think of that. You're very smart. Okay. Something else you can do. Anytime you multiply something by itself, you're squaring it. X times X is X squared. So X plus 6 times X plus 6, you could also write this as X plus 6 squared. That's the same thing. Both I would count correct. I don't prefer one over the other. However, technically, this is, I want to say it's a more simplified form. Very good observation. Good. Now. Cody always gets laugh. Oh, you guys crack me up. Okay, awesome. Anyway, with that being said, I am gonna go ahead and give you an exit ticket. If you have not been in a class with me before, an exit ticket is just the daily assignment I give you that will be due on Friday this week. Yesterday's exit ticket was to sign the math classroom agreement. If you did that, great, you're done. If not, and you don't know what I'm talking about, feel free to come and talk to me after class and I'll get you a copy of that. But I'm gonna go ahead and give you your exit ticket. I always try to make them very simple because I like to grade quickly. So let me write this for you.
You turn this in or before?
You turn this in, yes. And this is due by Friday. And something I try to do is after I've given you an exit ticket, if you are not here, what I'll do is I'll leave a copy of it in your folder. So anytime that you're not present, you won't need to ask me for this. It'll also be posted on Google Classroom. However, if you decide that you don't want a copy and you would rather write it out, the only thing I really want to make sure you do is write that it is the day 2 exit ticket so that I can keep track of which day it is when I put it in the grade book. It helps me out a lot. Okay, so for your day 2 exit ticket, I want you to factor the quadratic expression. I'm just gonna give you one today. I'll go easy on you.
Are you gonna make a copy of that?
Yes, I will. So if any of you want a copy, you're welcome to wait for it. I'll run and do that as soon as I finish writing it. As soon as I come up with one. My goodness. Let's see. That is it. This will be due on Friday. If you finish early, you are more than welcome to go ahead and turn that in, or you can, come show it to me when I get back. I'm just gonna write the due date on here.
There's only good seconds.
I'm just about to write your name if you are using my copy. Okay, all right, I'm gonna freeze that screen and end our recording. That is it for today.